Looking at the results of your multiple choice part, question number 9 seems to be the most boggling. So let's consider what was supposed to be done here. So Christy is testing values that would make triangle KLM, that's the biggest one, a right triangle. So she's testing the numbers that make it happen that this angle is a right angle. We know that ln is an altitude, so these markings should remind you about the situations with right triangles that we've discussed in class. Altitude drawn in a right triangle could be reduced to 2 rules. One would be about leg as a mean proportional, and the other is about altitude as a mean proportional. So we need to decide which of these rules would be used here. The trick of this question is that they do not give you much information in the very beginning. They just tell you this fact. And then they give you choices with different values and different pieces, which means that you can't really tell right away which of these two situations you have. And you literally have to work out every one of the 4 choices separately and see which of them makes sense. So I'm going to take this one for choice 1 and 2 and 3 and 4, and I'm going to mark this rule and this rule in different colors. So depending what it is that's given, for every one of the choices, we'll decide what would be more appropriate to take for every one of the situations. So number 1, LM is this, and KN is this. But I already noticed, and you should, that I don't have an altitude, I do have a leg. Therefore, whatever substitution will look like, this question will be about the rule where leg is a mean proportional. That was choice number 1. Let's go to choice number 2 and continue our analysis by placing the values in. LM is a leg, so we already know most likely it's the same rule. And NM, the other piece of the hypotenuse. So because a leg is involved, we are using the same rule in choice 2 if we wanted to check the substitution. Now let's continue and analyze the situation for choice 3. KL is also a leg. KN is a part of the hypotenuse, but it doesn't matter. Leg is given, therefore it's the same rule. And choice 4, LN is right here. Oops, that's our first altitude. This will be the rule in pink, where altitude over right triangle is a mean proportional. But just let's continue. And M is this portion. You have a part of the hypotenuse given. All right. So now that we analyzed it and got to review along the way, let's see which of these values actually will produce a viable proportion. So in choice 1, substitution begins with a leg. Your leg is LM 13, mean proportional. Must be between projection is this part. So if you knew this value is 6, and by given this is 16, then projection should be 10. So I have projection. I could write it here, or I could write it here. It really does not matter. So between projection and the hypotenuse itself, which is 16. Now we want to see if these two ratios form a proportion, which means that you either reduce this or that fraction, well, both of them actually, and see if left equals right. You also could dial this in the calculator, check the decimal, and could dial this in the calculator, check the decimal. If the decimals are not equal, then this is not a true equality. What I will do is I will check if the product of means equals to the product of extremes. This is 160. So, no, these two, left and right side, are not equal. So let's check situation number 2. The rule is leg mean proportional. For leg is LM. The value is 12. Between the projection, that's NM on our diagram, and the entire hypotenuse, which we know is 16. So we are checking if left equals right. So we know this product is 144, and now multiply these two. 10 times 9, that's 90, and 9 times 6 is 54. It does equal to 144. So choice 2 actually does produce the correct proportion, and therefore choice 2 is our answer. You can skip to the next question, but if you had difficulties with this one, you really should try to practice choices 3 and 4 just to see for yourself why they don't work. So I will continue. Choice 3, we said, will be leg as a mean proportional. KL is 11. And it is mean proportional between its projection, Kn, and the entire hypotenuse, which is 16. So we have 121 here, and 10 times 7, 70, and 6 times 7, 42. 70 and 42 equals to 112. So they are not equal. Although you can do it in your mind, of course I want you to check with the calculator because the stakes of this test are just way too high for us to make silly mistakes. Number 4, altitude was given, therefore it's this rule. Altitude is the mean proportional. So Ln, whose value is 8, that's our mean proportional. Between the two parts, this is part 1 and it's given Nm, 10. And then you'll have to figure that this has got to be 6 as a difference of 16 and the 10. So we are seeing 60 and 64 on the other side. And that's how we know that it's not a correct proportion. Next of the favorite questions happens to be this one. Parallelogram, generic word, such and such, has coordinates of only 2 points. Wonder why? Which statement would prove that this parallelogram is actually a rhombus? Them mentioning that already tells us that they want to use specific properties that make a parallelogram a rhombus. So we should remember there were 3 of them and then recall them later. These coordinates are plottable, so if you use a piece of paper, I think it's a good idea. But I will sketch it at this point. A, B, C, D. And at this point, it's enough for me to notice something special about points A and C. They have got to be opposite to each other. I wonder why. They are not a side, but they are are diagonal. Nobody mentioned that they are diagonal. We should have noticed that fact because that's probably related to one of the properties of a rhombus that they want us to use here. So I'm going to recall in my mind those properties, and you should too. Everything in black. These are 5 properties of a generic parallelogram. But these green 3 properties is what makes a parallelogram into a rhombus. So one of them is all sides are congruent. I suspect that is not something we can find from 2 points. Think of it. The only length you could find is the length of AC, of a diagonal. But there are no properties, special properties about lengths of the diagonals. What we know about them is that they have to be perpendicular to each other. And that is important. To each other means that maybe they're talking about the other diagonal that is not drawn. Maybe it's mentioned somewhere here. So this perpendicularity is very important. So once again, I ruled out this rule because A and C do not give me information to find the length of a side. AC represents a diagonal. Nobody said that. I derived that from the fact that you could draw the diagram and observe points A and C lying opposite to each other. And there is one more property that I will check. It's angles are bisected by diagonals. But the thing is that you cannot find angle measure from having coordinates of these 2 sides. Therefore, we will rule out this rule. So let's explore further the fact that diagonals must be perpendicular. First of all, if a segment is perpendicular to the other segment, then the products are -1. So to even begin thinking, if we have the situation, let's check what would be the slope of AC. Slope of AC. So if slope of AC is -3/1, then the perpendicular slope should be 1/3. And by the way, the name of that would be segment BD. Let's see if they say something about this. Slope BD is 1/3. Here it is. That is the answer. Now, how did I know to rule out these possibilities? Think of it yourself. They say midpoint of AC, so they are talking about this point. But midpoint is not one of the 3 rules that make a parallelogram a rhombus. That's how you could rule it out. Next, length of BD. That's kind of ridiculous to even talk about it because they didn't give us any information to find length of BD. And number 4, slope of AB. Slope of AB also could not be found because you don't have any information about B. So all that's left is choice 3. Okay, this is the next question that was quite popular to make a mistake in. Identify which sequence of transformations could map this figure onto this figure. So this is about identifying the type of a transformation. And notice the name they give you is in prime notation. So they're not trying to trick you here. It's pretty straightforward. As long as you remember to start with checking with the orientation. So let's see. Original A, B, C, D, E. From A to B to C to D to E. That is a clockwise direction. So the prime notation is counterclockwise direction. Therefore, and I haven't even looked at the choices, this transformation represents some sequence that definitely includes reflection in a line. Number 1 doesn't have anything like that. Number 2 doesn't have a reflection in the line. Now you could tell that, of course, by reading carefully through the choices and identifying the keywords. Number 3 has line reflection followed by a translation, so it was sliding afterwards. And number 4, line reflection followed by a line reflection. And that is a curious case. Imagine a line reflection that produces change of orientation. And then change of orientation would happen again. This means that orientation will become the same as the original image. So it will be the same orientation, no flip. That's not what we are observing here. Therefore, this is not a possibility. Choice 3 is the answer. Okay. Next one, point Q is on a segment so that the segment is divided in this ratio. So it's segment partition. Once you recognize it, you should remember to create a diagram. So I now have a segment. Breaking this segment in a ratio 2:3 means that our final result will look somewhat like this. Q will be on the segment MN, 2 units away from M and 3 units away from N. And remember that we can use this diagram to complete it to a right triangle. The benefit of it is that we can definitely say what the length of vertical and horizontal segments are, because we can count the units. And once we know the length, we could tell what 2/3 of that length would be. We cannot do the same with a slanted segment because we simply do not know its exact length. Now, once we have that triangle, we can scale down each side the same way side MN is scaled down to side MQ. What does it mean? It means that there would be 2 parts and 3 parts of this vertical side that we will be able to identify using one of the points. I don't know exactly if this point is here, but we'll figure it out right now. So what we do for that is realizing that since 2 parts and 3 parts represent multiples of some numbers, we can just write them as an expression, 2x and 3x for the vertical segment. And then write the entire length. Count the units. Okay, so now that we have these values, they simply mean that 2 units, 2 parts become 4 lengths starting from M. 1, 2, 3, 4. So I was actually pretty good with guessing. All right, and there would be 6 lengths of squares right under, which is exactly what it is. So this point projected onto the hypotenuse gives us an estimate of Q being right here. We'll just have to verify it by repeating all these steps with the horizontal segment, just in case. This means that now, starting again from the location of point M, that is right here, its projection, I will count off 2 units. The value of each is 1, so it is 2 lengths. And then there will be 3 parts left. So from this point now, I will do projection onto the hypotenuse and ta-da! This is your Q. Let's read the coordinates of that Q. Be careful Make sure to begin with the origin. Get the x value. 1, 2, 3, 4, 5. 5, 1. 5. Next question. I'm looking at the answer choices. It looks like they want you to recognize relationships from the diagram, not necessarily applying a rule directly. So read this question carefully. They're talking about a reflection over a line. They're talking about dilation with a scale factor. Does it mean necessarily that we will be plotting something? No. But it does mean that orientation will change. If you continue your analysis, there is nothing in the choices that indicate that they're working with orientation. So maybe they want you to notice relationships that come from dilation, which is similarity. Notice what they're discussing. Possibilities are all about angles. That means that you have to recall relationships of angles in similar figures. And angles are congruent as long as they are corresponding. So, which angles are corresponding? You should not be deciding it without labeling your diagram. You should use the notation of the triangles here to mark corresponding angles. So, triangle ADE on the right, angle A is meant to be right here. And corresponding angle A in triangle ABC, the one on the left, means that we are right here. They must be congruent. Please do not mark them this way, because then it will be, well, I mean, close to each other, because it will be difficult to notice their relations. All right. Next is a pair of angles D and B, so that is right here. And then C and E, the angle right here, and angle right here. Okay, so now let's analyze one by one their choices, because you need to find who these angles are before you make a decision about them. BAC, BAC is right here. And AED, AED is right here. These are definitely not corresponding angles. We're talking about vertex A and vertex E. So that's not choice 1. Let's do choice 2. Angle ABC, ABC, and angle ADE, ADE. Oh, these two are definitely corresponding and they are congruent. So I very much suspect that 2 is our choice, but I will check the result. You never know. Angle DAE, DAE is a half of angle BAC, BAC. That is not true, because both of these angles are congruent and they are each a half of angle BAD. And that's how we know 3 is not our choice. And last situation, angle ACB, ACB equals to half of angle DAB, DAB. Well, maybe it is true, maybe it's not. There is nothing here that tells us for sure that that's the fact. And therefore, you cannot make that conclusion. Therefore, choice is 2. And this is my personal favorite. Although they were very generous with the answer choices and didn't include the really confusing possibilities. So, 2 points are graphed, giving us a segment BC, and what happens is a dilation centered at point A. So dilation is not centered at the origin. This means that you cannot simply multiply coordinates by the scale factor. Dilation centered at a random point such as A means that you will actually need to do the construction to find the prime points. And what you have to remember during construction of dilation is that when you have a positive coefficient of dilation, your image will be on the same side as the original if you're looking from the center of dilation. So I am anticipating my new image to be below A because that's where the original is, and therefore it would be somewhere right here. It's good to make an estimate. You also have to remember that when there is dilation, 2 in this case, not only sides or lengths will increase 2 times, but betweenness will as well. And I will begin with actually making the lines of sight first. From the center of dilation through each of the points. Be as neat as you can, and then through the point of dilation and point C. I have a grid, so I will use this to make sure that I count off the slope, to make sure that my images are not distorted here. So to get from A to B, it took me 1 down, 1 to the right. That would be 1 betweenness. And I, with the coefficient 2, will need 2 of these betweennesses. Remember, very important, betweenness is the space between the center of dilation and the point of interest. This is betweenness for point B, but twice that, 1, 2, will be betweenness for point B prime. 1, 2. This is 2 because coefficient of 2 was applied to 1 betweenness. Okay, to get from point A to C, I had to drop 3 and move to the left. That is my single betweenness. And from A to C prime, I will have to apply the same betweenness 2 times because of the factor of dilation. So once, and then drop 3 and move over 1. Here is my C prime. If you wish to connect them, you can, but really your question is about finding coordinates of these 2 points. Connecting them just allows you to see or verify that one segment is twice the size of the other and that they're still parallel, because that they have to be parallel segments after dilation. So now you just have to read the coordinates very carefully, again from the origin. It is 5, 2, but I have 2 possibilities, so be very careful. And C prime, 1 minus 2, 1 minus 2. This makes choice 1 a correct one. That would not be choice 4. Okay, some of you were confused with this question. It's good for you yourself to know what exactly confused you. We need to find the value of x, which is in one triangle. And tangent of angle theta is given using the other triangle. When they give you 2 triangles, you really should be thinking right away, are they congruent or are they similar? These 2 are similar. Why did they say they're similar? The only reason would be that there is something important from that fact. So let's recall what we know about similar triangles and the angles, because they seem to be working with an angle and then with a side. So if the 2 triangles are similar, whether they're right or not right triangles, at this point, their corresponding angles must be equal. How do you know which angles are corresponding? Well, this is a 90 degree, this is a 90 degree. This is a single curve, and this is a single curve. This tells us that angle theta right here is the same as angle theta up here. Once again, that is the fact that in similar corresponding angles are congruent, like this angle C and F, and based on that, their sines would be congruent. So will be their cosines, and tangents also will be congruent. So even if you don't know what to do next, why don't you start with writing out the fact about tangent that is given, and then go back to your memory. We use tangents in the context of right triangles, where we would always label that right triangle, and we would recall that tangent is a ratio of opposite side to adjacent. So let's label our triangle. Right across from a right angle would be the hypotenuse. Remember, if your alligator is at the angle of interest right here, then one side is a hypotenuse and the other one would be adjacent to it. Adjacent to angle theta, which makes this angle opposite to angle theta. So now you can set up the ratio using the triangle on the right. Tangent of theta based on this triangle is opposite side, 2 4/10, over adjacent side, which is your x. So one fact comes from the triangle on the left, the other fact comes from the triangle on the right. But the truth of the matter is that they are describing tangent of the same angle. This means that they are equal. And you can continue with the ratio that 3/7 is the same thing as 2 4/10 over x, solving this by cross product. And solving this proportion will get us a result 5 6/10, choice 2. Another trigonometry question. Once you realize it's a right triangle, acute angle is involved, you should know that it's not Pythagorean theorem but trigonometry, which means that you have to label your triangle, identifying opposite and adjacent sides, and then you will have to pick an appropriate ratio. So you will write your SOHCAHTOA and begin identifying those elements that you can easily substitute. Since it's trigonometry, you will be able to work with sine, cosine, and tangent. We will underline them. Opposite from the right angle is a hypotenuse, and you do have hypotenuse in 2 of these ratios. And then remembering that you have an alligator right here helps you see that one side is a hypotenuse and the other side is adjacent to angle 40 degrees. Therefore, you have adjacent side. This means that the only ratio that would allow you to do the substitution would be cosine. So no sines for us, no tangents. You now will write out the ratio of cosine and solve it. You will have to remember while using a calculator to make sure that the calculator is in degrees mode. By the way, of course, you had to do the same for the previous question. About 18 is the result, so to the nearest foot, the answer choice is choice 3. Next, before even reading, I'm noticing there are 2 triangles, so I'm thinking it's about congruence or similarity of triangles. Reading for keywords allows me to notice that they make it a point to mention there is an intersection. Usually it has to do with the angles, vertical angles, because you cannot just assume that on any picture that appears this way you will have vertical angles. It's only if you know for a fact that they are formed by two intersecting lines or segments, like in this situation. Now they said this fact: always beware of a statement about parallel lines and transversal, because of course that means a relationship of special angles. So whether you will say B and E are congruent, or A and D are congruent, you would be right. But you only really need one pair of angles, because you have a pair of vertical angles and a pair of angles formed by parallel line and transversal. So now you know for sure that these two triangles are definitely similar. Now let's read on and put all the information on the diagram. Remember, it is important to mention on the diagram not just the given information, but what it is that you're looking for. So now I will be able to write a similarity statement for these two triangles. With this, I will be able to write ratios of corresponding sides. Recall these relationships we've discussed earlier. I will take a smaller triangle, or what appears to me a smaller triangle, and relate all the corresponding sides. That's how verbally that proportion is described. And on this example, my proportions will look this way. I now will be able to do substitution with numerical values. I now need to pick a couple or two ratios that make the proportion. I cannot take these two because there will be 1, 2 unknown. So this seems to be an obvious choice, which when I solve by cross product will give me the value of x. And according to my diagram, the value of x is my answer. I'll just have to round it to the nearest hundredths. Notice that this throughout the problem I didn't mention anything about the units. It's not because I didn't pay attention to them. It's because I noticed that they were talking about centimeters and their final question is about centimeters. So there is no conversion that is needed. Please notice that they are working with decimals, which makes it possible to make silly mistakes such as substitution or confusing your decimal point with actually multiplication. So it's probably a good idea anytime you work with decimals to put parentheses around one of the multiples. Well, the result of solving this equation will produce the value of x, 8 and 25 hundredths. That's how we know the result is choice 4. Okay, some of you do need to review this kind of questions. So, which equation of the given represents a line that passes through the given point and at the same time is perpendicular to the line whose equation is given? They're being very generous here. They are not giving you an equation that needs to be solved for y. But please remember that you need to solve it for y at all times. Writing out the slope of this equation and finding out the slope of perpendicular requires that we remember it will be opposite, reciprocal. So slope would be simply minus 2, which allows us to cross out choices 1 and 3. And the rest is a business of substitution. If you remember the fact that a point belongs to the line, if x and y values of that point make your equation true, then by substitution you shall find the equation that is perpendicular to the given line and passes through point minus 2, 7. Just don't confuse substitution for y. It's the first value you see, so don't accidentally pick the first value in your point. Okay, so we just found our solution, that is choice 4. Which rotation about its center will carry a regular decagon onto itself? Onto itself means that they're talking about symmetry. Decagon means that you're talking about 10-sided polygon. And we could draw one, but there is really not much need. If you remember that the number of sides, 10, is the same as number of central angles formed inside this figure around the center. And the central angles all will be equal because we are talking about a regular decagon where all sides are equal. At the same time, all of these 10 angles together through partition of angles are added up and produce 360 degrees, which means that if you divide 360 by the number of angles, you will find that each of these angles is actually 36 degrees. So, every time you turn 36 degrees, you will not be able to tell the original from the image. You could do it more than once. So, any multiple of 36 degrees, where multiple stands for the number of times you apply that rotation, will produce such figure. You do not see the answer 36 in the choices because one of these guys is meant to be the multiple of 36. So you just have to see if a number is divisible by 36. The only number that is divisible by 36 is 252, and that is why that is the answer. Okay. There are two triangles and they are congruent. Which statement is not always true? So you have to remember the properties of congruent triangles, which means that they probably will be talking about the fact that corresponding angles are equal, corresponding sides are equal. And basically, this triangle is congruent to itself, and therefore everything that's inside we call area would be congruent. Everything that's outside we call perimeter will be congruent. So comparing these two triangles and their areas or perimeters will help us see that these choices 3 and 4 are always true. So that's not what we're picking. Now let's take a look at angle A and D. Are they corresponding? Because if they are, this is A and D, they are, then the statement is true. So let's now check side BC, last two positions, and DF. Oh, here it is. DF and BC are not corresponding sides, therefore you cannot say that they are always congruent sides. It might be sometimes, but you cannot insist that it's always true. Therefore, 1 is the choice. Another transformation question. Gotta read it carefully to make sure that you're focused on every word and actually visualize the situation. Of course, this word not is very important. They are using prime notation, so they're not trying to trick us. So there is an image and the original, and they're not congruent. That right away tells us that we're dealing with something that is not a rigid motion, and the only transformation we know produces a new image not congruent to the original is dilation. No dilation in first 2 choices or first 3 choices. Choice 4 is the only one who has the dilation.